Hi everyone, welcome to lecture 2 of Technical Mathematics, Matrices and Determinants Part 2. In this lecture, we are going to discuss about algebra of matrices, transpose of a matrix, results related to transpose of a matrix, determinant of a matrix, and identification of matrices. So let's begin our discussion with algebra of matrices. There are three operations in algebra of matrices. They are matrix addition, matrix subtraction, and matrix multiplication. First, let's discuss about matrix addition. Matrix addition is possible among two matrices if and only if they have the same order. Here, we have an example. In this, we are adding two matrices. You can see that the order of first matrix is 3 by 2. Similarly, the order of the second matrix is also 3 by 2. Therefore, addition is possible among these two matrices. Now, how addition is performed? We have to add corresponding elements. Here, first element of row 1 has to be added with first element of the second matrix. So, that is done here 1 plus 0. We are getting the result as 1. Now, here the second element is added with second element of the second matrix. So, 3 plus 0. We are getting the result as 3. So likewise, we have to add elements corresponding to different positions and we are getting the resulting matrix. And you can see that order of this resulting matrix is same as that of the matrices undergoing the addition process. That is, here if you check the order, you can see that it is also 3 by 2. Okay. Now matrix subtraction is same as that of matrix addition. The only difference is that the operation what takes place is subtraction. So here also you can see that the order must be same and the resulting matrix will also have the same order as that of the matrices undergoing subtraction process. Okay, now let's move on to matrix multiplication. For matrix multiplication, the condition to be satisfied is that number of columns in the first matrix must be equal to number of rows in the second matrix. So that is the condition to be satisfied for matrix multiplication. Suppose we are going to multiply two matrices A and B with order m by n and n by p. This multiplication is possible because here number of columns of the first matrix is n and number of rows of the second matrix is again n. Therefore, A into B is possible. So the condition to be satisfied is that number of columns in the first matrix must be equal to the number of rows in the second matrix. This is an important condition that you have to remember, the condition for matrix multiplication. Now, the resulting matrix will have the same number of rows of the first matrix. Number of rows of the resulting matrix will be equal to number of rows of the first matrix and the number of columns of the resulting matrix will be equal to number of columns of second matrix. Okay, so let's again consider the example of multiplication between two matrices A and B. Here, suppose our resulting matrix is C, then C will be having an order of m by p. It will have the same number of rows as that of A and it will have the same number of columns as that of B. Okay, so when we multiply A with B, the resulting matrix C will have an order of m by p. Now let's see an example for matrix multiplication. Now here we are having two matrices A and B. We have to calculate A into B. So first let's check whether it is possible to multiply A with B. You can see that here order of A is 2 by 3. It is having 2 rows and 3 columns. So order is 2 by 3. And matrix B is having an order of 3 by 2. It is having 3 rows and 2 columns. Now let's check the condition for matrix multiplication. The condition for matrix multiplication says that the number of columns of the first matrix must be equal to number of rows of the second matrix. So that is true here. We are having number of columns of A as 3 and number of rows of B is 3. Therefore, A into B is possible. Now what about the order of resulting matrix? Here order of the resulting matrix will be equal to 2 by 2. Okay. So if we are multiplying A with B and if the resulting matrix is C, then it will have an order of 2 by 2. And we can represent a 2 by 2 matrix like this. Elements will be A11, A12, A21 and A22. And how to obtain A11? A11 can be obtained by multiplying first row of the first matrix with first column of the second matrix. So we have to multiply first row of the first matrix with first column of the second matrix. So when we multiply this row with this column, we will get the first element A11. So you can see that here 1, 2, 3 is getting multiplied with 1, 0, 2, and the value of A11 can be calculated like this. So 1 into 1 plus 2 into 0 plus 3 into 2. So that is how we calculate value of A11 and we are getting it as 7. Now coming to A12, A12 can be calculated by multiplying first row of matrix A with second column of matrix B. Okay, so we have to multiply first row with second column. So multiply 1, 2, 3 with 1 minus 1 minus 2. We will get the value of A12. So you can see here that multiplication is taking place between first row and second column. So 1 into 1 plus 2 into minus 1 plus 3 into minus 2. So that's how we calculate the value of A12 and we are getting it as minus 7. Similarly, we can calculate A21 and A22. A21 can be obtained by multiplying second row of matrix A with first column of matrix B. That's how we obtain A21. Okay, and similarly A22 can be calculated by multiplying second row of A with second column of B. Okay, so if you calculate, you will get it as minus 3. So the resulting matrix C will be having elements 7, minus 7, 1 and minus 3. Now let's see one remark corresponding to matrix multiplication. Matrix multiplication is non-commutative. That means A into B need not be equal to B into A. Let's check this by looking into an example. Suppose our matrix A is a 2 by 3 matrix and matrix B is a 3 by 2 matrix. When you multiply A with B, resulting matrix will be having an order of 2 by 2. We will consider that matrix as matrix C and the order of matrix C will be 2 by 2. Okay, it will be equal to 2 by 2. Now, if you are multiplying B with A, what will be the resulting matrix? What will be the order of the resulting matrix? You can see that order of the resulting matrix will be equal to 3 by 3. So it's an entirely different matrix and we are denoting it as matrix D. Okay, so when we are performing multiplication between A and B such that A is multiplied with B, we are getting resulting matrix as matrix C, which is of order 2 by 2. And when we are multiplying B with A, we are getting a different matrix as the result, that is matrix D, which is having an order of 3 by 3. So this implies that matrix multiplication is non-commutative, that is A into B need not be equal to B into A. Okay, now let's discuss few questions related to the topics what we discussed just now. Question number 1. Two matrices A and B are multiplied to get AB if option A says both are rectangular, option B says both are having the same order, option C says number of columns of A is equal to number of rows of B, and option D says number of rows of A is equal to number of columns of B. So just pause the video and try to answer this question by yourself. I hope you have the answer with you. Let's check the answer. Here the correct answer is option C. Number of columns of A is equal to number of rows of B. So it's a direct question. This is derived from the condition for matrix multiplication. Question number 2. A matrix X has A plus B rows and B plus 1 columns, while the matrix Y has A minus 2 rows and A plus 2 columns. Both the matrix X into Y and Y into X exist. Then A and B are. We are asked to calculate values of A and B. Okay, so you may try this question by yourself. Try to solve this by yourself. Just pause the video and try to solve this. Okay, now if you have the answer, let's check the answer. Here it is said that X into Y and Y into X exist. So X into Y exist. This implies that number of columns of X is equal to number of rows of Y. Okay, so here in the question it is mentioned that matrix X is having A plus B rows and B plus 1 columns. So number of columns of X is B plus 1. Okay, that will be equal to number of rows of matrix Y. So Y is having A minus 2 rows. Therefore, B plus 1 must be equal to A minus 2. Okay, and again in the question it is said that Y into X exist. Y into X exist. So what is the meaning? It means that number of columns of Y is equal to number of rows of X. Okay, so here number of columns of Y. In the question it is given that matrix Y is having A plus 2 columns. So A plus 2 is equal to number of rows of X. X is having A plus B rows. So A plus 2 is equal to A plus B. Okay, now we have two equations corresponding to unknowns A and B. So by solving equations 1 and 2 we can calculate value of A and B. So from 2, equation number 2, we can say that value of B is equal to 2, because here if you cancel A and A we get B equal to 2. So we are getting the value of B straight away from equation number 2. Now we can substitute this value of B in equation number 1. So this implies that equation number B1 can be changed like this. Substitute value of B here. B is equal to 2. So 2 plus 1 will be equal to A minus 2. So this implies that A is equal to, you take this minus 2 to the left hand side. So that becomes plus 2. So 2 plus 2 plus 1. A value will be 5. So B is equal to 2 and A equal to 5. That's the answer. So here the correct answer is option A. A equal to 5 and B equal to 2. Okay. Now let's discuss about transpose of a matrix. For a matrix A, its transpose is denoted by A raised to T. So we will read it as A transpose. In some cases, it is also represented as A dash. Now, A transpose is a matrix whose rows are the columns of A. So, rows of A transpose will be equal to columns of the actual matrix A. Now, if A is an m by n matrix, then A transpose will have an order of n by m. That is just the reverse of the actual matrix. So the actual matrix is having an order of m by n. Therefore, A transpose will have an order which is equal to n by m. Now let's see an example. Suppose our matrix A is equal to 1, 2, 3, 4, minus 1, 0. Then what will be A transpose? So in this case, A transpose will be equal to the first row of A transpose will be equal to the first column of matrix A, that is 1 4. 1 4 will be the elements coming in row 1. Now row 2 of A transpose will be equal to column 2 of matrix A. So column 2 consists of elements 2 and minus 1. So therefore row 2 will have elements 2 and minus 1. Now row 3 of A transpose will be equal to column 3 of matrix A. So here elements are 3 and 0. So in third row of A transpose we will have elements 3 and 0. So this is A transpose corresponding to matrix A, that is transpose of matrix A. Now let's see the order. Matrix A is having an order of 2 by 3, and here we can see that A transpose is a matrix with 3 rows and 2 columns. Therefore order will be 3 by 2. So you can see that orders are just the reverse of one another. Here in matrix A order is 2 by 3, and in A transpose the order is just the reverse, that is 3 by 2. Now let's look into few results related to transpose of a matrix. First one, A transpose whole transpose is equal to A. A transpose whole transpose is equal to A. That is, if you find out transpose of a matrix, then you will get the original matrix A itself. Okay. Now second one, A plus B whole transpose is equal to A transpose plus B transpose. Okay. Now the third one, A into B whole transpose is equal to B transpose into A transpose. A into B whole transpose is equal to B transpose into A transpose. Now fourth one, K into A whole transpose is equal to K into A transpose. Okay, these are the few results related to transpose of a matrix. Now let's solve one question. Question number 3. Question goes like this: if A is a 3 by 4 matrix and B is a matrix such that A dash B and B A dash are both defined, then B is of type, option A says 4 by 3, option B says 3 by 4, option C says 3 by 3, and option D says 4 by 4. So you may try to solve this by yourself. Please pause the video and try to solve this by yourself. Okay. Now if you have the answer with you, you may check the answer. Here the correct answer is option B, 3 by 4. Let's see how to solve this. So here we have a matrix A whose order is known. Its order is 3 by 4. Okay. So if order of A is 3 by 4, then what will be order of A transpose? A transpose will have an order of 4 by 3. Okay. And now in the question it is given that A transpose B and B A transpose are both defined. So multiplying A transpose with B, that is possible. Similarly, multiplying B with A transpose, that is also possible. Okay, so A transpose B exists means the matrix A transpose having an order of 4 by 3 can be multiplied with a matrix B. Now the order of B is unknown to us, but it is said that A dash can be multiplied with B. That means this implies that B will have an order of 3 by something. Okay, from this hint we can say that the number of rows of the second matrix B will be equal to 3, because here A dash into B, that multiplication is possible if and only if the number of columns of A becomes equal to number of rows of B. Okay, so therefore from this hint we can derive the value of number of rows of B. Number of rows of B will be equal to 3. The same way, another hint given is B into A dash is also possible. So what does it mean? It means that we can multiply matrix B with a matrix which is denoted as A dash and having an order of 4 by 3. So this multiplication is possible if and only if the number of columns of B is equal to 4, because we can multiply B with A dash, if and only if the number of columns of B is equal to number of rows of A dash. So here B into A dash is possible if and only if number of columns of B is equal to number of rows of A dash. So from these two we can obtain the order of matrix B. B will have 3 rows and it will have 4 columns. So B is a 3 by 4 matrix. So therefore correct answer is option B, 3 by 4. Now let's see what is determinant of a matrix. Determinant of a matrix is a function from the set of all matrices to set of real numbers. So it's a function that maps a matrix to a real number. Now how we denote determinant of a matrix? Here determinant of matrix A is denoted like this. We can also denote it like this. Okay, let's consider a 2 by 2 case. How to calculate determinant of a 2 by 2 matrix? Say suppose we have a matrix A which is of 2 by 2 size, and if the elements are A11, A12, A21 and A22, we can use this formula to calculate the value of the determinant. So determinant of A will be equal to A11 into A22 minus A12 into A21. So using this formula we can calculate determinant of this matrix. Okay, let's see an example. Suppose we have a matrix A with elements 1, 2, minus 3 and 1. How to calculate determinant value? You can see that using this formula we can calculate determinant value like this. Okay, determinant of A will be equal to determinant of 1, 2 minus 3, 1. That will be equal to 1 into 1. 1 into 1 minus 2 into minus 3. 2 into minus 3. So we will get the result as 7. Now coming to a 3 by 3 case, when we have a 3 by 3 matrix like this one, we can use this formula to calculate determinant of the given matrix. So how to obtain this formula? We have to consider the first element, that is A11. A11 comes here. Just omit row and column containing A11. We will have a set of elements left out. Find out determinant of the matrix containing these 4 elements. Multiply that with A11. That is how we get this first part. Okay, now coming to this second part. This second part is having minus sign. Here along with A11 we were having plus sign. So in the second part we will have a minus sign. We have to put alternate plus and minus signs. So A12 is assisted with a minus sign. Now minus A12 into determinant of the elements which are left out after omitting row 1 and column 2 of the given matrix. So A12 is this element. It belongs to row 1 and column 2. So omit row 1 and column 2. Left out elements are these 4. Find out the value of the determinant with these 4 elements. So this is that determinant value. Multiply that determinant value with A12. Then plus. Here we were having minus sign, so here it should be plus A13. A13 is the element that comes in the first row and third column. So A13 into, just omit row and column containing A13. We will have these 4 elements left out. Find out determinant of the matrix having these 4 elements. Multiply that with A13. So we get this. So this is how we obtain this formula to calculate determinant of a 3 by 3 matrix. Now let's see an example. Here we have an example matrix given A equal to 1, 2, 3, 2, 1, 4, 1, 1, 2. Now let's try to calculate determinant value of this matrix using this formula. So if you calculate, we will get like this. Determinant of A will be equal to A11 is 1, so 1 into determinant of A22, A23, A32 and A33. So those values are 1, 4, 1, 2. So that comes here 1, 4, 1, 2. Okay, so similarly using this part we can calculate the matrix determinant value. Okay, so if you do the calculation, finally you will get the value of determinant as +1. Now let's familiarize a shortcut method to find out determinant of a 3 by 3 matrix. Suppose our matrix is this one. We can make use of the direct equation that we just learned to calculate the determinant value, but we have a simple method to calculate the determinant value. So that is this one. Okay, so what we have to do is just write the elements present in the matrix in the same order as given in the matrix. Okay, now write the first column once again, 1, 2, 1, followed by the second column, 2, 1, 1. Okay, now just consider elements in the diagonal fashion. Okay, multiply these elements. Okay, so that is 1 into 1 into 2. Okay, plus the second diagonal is this one, consisting of 2, 4 and 1. Okay, so 2 into 4 into 1 plus the third diagonal is this one, 3, 2, 1. Okay, so 3 into 2 into 1. Okay, minus, just consider the off diagonals. Off diagonals are these diagonals. This is the first off diagonal, 3, 1, 1. Okay, so minus 3 into 1 into 1. Okay, minus the second off diagonal is this one, 1, 4, 1. Okay, so minus 1 into 4 into 1. Okay, minus the third off diagonal is this one, 2, 2, 2. Okay, so minus 2 into 2 into 2. Okay, so if we calculate the values, then what we get is, we had 2 plus, here we get 8, 8 plus, here we get 6, 6 minus 3 minus 4 minus 8. So this 8 and this 8 gets cancelled. Okay, so the resulting value will be 2 plus 6, 8 minus 3, 5 minus 4, that is 1. So this way we can calculate determinant value. Now let's discuss one question. Suppose that A is a 3 by 3 matrix and determinant of A is equal to minus 3. Then determinant of 4A is. So here the question is, we have a 3 by 3 matrix given and the determinant value is also given. We have to calculate determinant of 4A. So if you have a matrix A with an order n by n, and if its determinant value is known to us, we can calculate determinant of Ka by using the formula k raised to n into determinant of A. So here k is a scalar. So we can make use of this formula to solve this question. So here determinant of 4a will be equal to 4 raised to 3 because the given matrix A is a 3 by 3 matrix, therefore n value is 3. So 4 raised to 3 into determinant of A. Determinant of A is given as minus 3. So 4 raised to 3 into minus 3. So that will be equal to minus 192. So here answer is option C, minus 192. Okay, now let's move on to identification of matrices. Here we have two types of matrices, symmetric matrix and skew symmetric matrix. A matrix is said to be a symmetric matrix if A transpose is equal to A. Here we have an example. A matrix A is given as 4, 2, 2, 4. Its A transpose will be equal to, the first row will be equal to the first column of the actual matrix, that is 4, 2. So that forms a row 1 of A transpose 4, 2, and the second row is taken from second column of matrix A, that is 2, 4, 2, 4. But you can see that the resulting matrix A transpose is same as that of the actual matrix. Therefore, the matrix is a symmetric matrix. So symmetric matrix is a matrix in which A transpose is equal to A itself. Okay, now what about skew symmetric matrix? A skew symmetric matrix is a matrix in which A transpose is equal to minus A. So let's see an example. Suppose our A is equal to 0, 2, minus 2, 0. When you calculate transpose of A, we will get it as 0, minus 2, 2, 0. The first row is taken from first column of the actual matrix. So 0, minus 2, 0, minus 2. And second row is taken from column 2 of the actual matrix. So here the second row is taken from column 2 and elements are 2, 0, 2, 0. Now you can see that this matrix is nothing but minus A. Therefore, the given matrix A equal to 0, 2, minus 2, 0 is a skew symmetric matrix. So for a skew symmetric matrix, the transpose of that matrix will be equal to minus of the actual matrix. Okay, so that is skew symmetric matrix. So here the peculiarity of skew symmetric matrix is that all diagonal elements will be equal to 0. So diagonal elements of a skew symmetric matrix are zeros. Okay, now there are two results related to these two types. That is, A plus A transpose is symmetric. A plus A transpose is symmetric. And another result is A minus A transpose is skew symmetric. A minus A transpose is skew symmetric. Okay, now let's see another type of matrices, that is orthogonal matrix. A matrix is said to be an orthogonal matrix if A into A transpose is equal to I. Here I is nothing but identity matrix of order same as that of A. So A into A transpose, if it is equal to I, then such a matrix is called an orthogonal matrix. It can be said in another way, we will see this definition later. A transpose equal to A inverse. If transpose of a matrix is equal to its inverse, then that matrix is a orthogonal matrix. We will discuss that point later on. Okay, now let's see one question related to these topics. Question number 5. If A and B are symmetric matrices of order n, then option A says A plus B is skew symmetric, option B says A plus B is symmetric, option C says A plus B is a diagonal matrix, and option D says A plus B is a zero matrix. And in the question, a hint is given, A is not equal to B. So here, let's try to solve this. Suppose we are calculating the transpose of A plus B. A plus B whole transpose will be equal to A transpose plus B transpose. This is as per the results related to transpose. A plus B whole transpose is equal to A transpose plus B transpose. And in the question, it is given that A and B are symmetric matrices. So if A is a symmetric matrix, then its transpose will be equal to A itself. So A transpose can be written as A. Similarly, if B is a symmetric matrix, then B transpose will be equal to B. So B transpose can be replaced with B. So from this, we may say that A plus B whole transpose is equal to A plus B, and therefore A plus B is symmetric, right? A plus B whole transpose is equal to A plus B. That is what we are getting. So here option B, that is A plus B is symmetric. This option is the right answer. Okay. Now with this we are coming to end of lecture 2. In lecture 2 we discussed about algebra of matrices, addition, subtraction and multiplication. Then we discussed about transpose of a matrix, and also we discussed about few results related to transpose. Then we discussed about determinant of a matrix, both 2 by 2 case and 3 by 3 case. And we discussed one shortcut method to calculate determinant value of a 3 by 3 matrix. And then we discussed about identification of matrices. Okay, in lecture 3, we will discuss about properties of determinants, and we will solve few problems related to properties of determinants. Now for upcoming videos, you may subscribe to our YouTube channel, Vadhyar Online Academy. And for study materials, you may subscribe to our Telegram channel using this link. And this link is given in the description of this video. So see you in lecture 3. Goodbye.